Great. Well, thank you, everyone, for joining us once again for our breakfast briefing. As usual, we have quite a few slides and a lot of information that we're going to cover, and they'll be made available for you. We're going to do our best to actually send it out within the next few hours. So anyone who's registered for the briefing, if you haven't registered, either go to our website, sign in on the sheet with your email address, or leave a business card. We'd appreciate that. So on our agenda, what we're going to do a little differently this year is we do a lot of different studies, as you've seen in the past, but we're going to give you a snapshot of each of about 12 studies we've done recently. And if you're interested in information on them, most of them are available, at least in parts or in whole, for the whole community. And so we want to give you just a sampling of that. And then we'll get into an update on the HPC market itself, the cloud computing tool that we created and made available for the community, and quantum computing, the Exascale Race, and then the fun part is the Innovation Award winners for this year. And for the conclusions, we're going to include a handful of predictions we're making about what we think is going to happen in the market in the next year or two. If you're not familiar with our team, myself, Earl Joseph, Steve Conway couldn't make it because he's launching the Industry Day right now. Bob Sorensen, Alex, Mike, and Kurt are here. So this is our primary research team. We do have about another 8 part-time people that are also part of the team that aren't shown here. So here are the primary research activities that we do. We do our best to track every HPC system sold around the world. And we are now tracking that by 28 countries, 12 verticals, and we're adding 4 new verticals related to AI into the data structure right now. The user forum we'll talk about a little bit, and I just wanted to highlight the government studies that we do. When I mentioned we're doing a lot of new studies, a lot of additional ones, and we'll show you snapshots. The nice thing about government studies is governments usually then want it made available to the world for as, a matter of goodness. And so you'll be seeing a lot of results from that. In particular, we are tracking all quantum computing research activities around the world. We've just launched a study on that. We're launching a study to track all AI research activities. So we're trying to create these global trackings of what's going on, and of course try to figure out who's going to buy what then from all that tracking. And our next user forum meeting is going to be at Argonne. We're hopefully the first UX exascale system will be installed, and we always invite everyone to join the user forum. It's led by a steering committee of end users, and I think about half the steering committee are in the audience, so I want to thank everyone for helping out on that. We really appreciate it. We're also going to have 2 European meetings this year in October in both Switzerland and then in Scotland. And we're going to have 2 Chinese meetings in late August. We're just finalizing the details on those meetings, and we're very excited about that. And you'll be getting an update on the Chinese meetings very soon. Don't quite have the agendas ready, but we're getting very close. So with that, I'd like to start with some of the sample projects I mentioned. So first of all, we've done a lot of work on big data, AI, and we're trying to figure out where the market is, where the buyers are. And this is the priority rating right now that we see for the market. So precision medicine is a more longer-term one. There isn't a lot of purchases taking place right now. But from everything we're looking at, we think that's going to be the largest market. Automated driving systems is where the money is going right now, so there's always already a lot of spending. And for each one of these, we subdivide them into about 8 other subcategories, and fraud and so on. So these are the top rankings that we did in one study to figure out where the real money is going to be as far as investing in AI and big data systems. This shows our new forecast for the whole AI area. You'll notice, if you remember our forecast from last year, we have made a substantial change. We don't think that deep learning is going to grow as fast as we were saying previously, because we think machine learning is going to really be dominant for the next 5 years. And if you remember last year, our forecast had deep learning taking over by the end of 5 years. We don't see that really happening. But if you notice the growth rates on everything there, AI is the thing that's growing the most. They're all in the 25 to 30% growth areas there a year. And to have a CAGR over 5 years of 25%, let alone 30%, is substantial, because that's a tremendous growth area. I think a lot of you are familiar with the return on investment research we've been doing. If you go to the website, you can actually download over 700 examples of success stories in HPC that show the return on investment either in financial terms or in scientific terms. If you look at the financial part of it, right now, again, we're collecting large data sets, so every time we add more data to it, the numbers move around. But for the ones that are doing financial return, for the average of revenue generated per dollar invested in HPC is around 463 right now. Sorry, the M shouldn't be on this chart. A small error in the chart will clean that up. The average profit per dollar invested in HPC is running $44. So the return on investments are extremely high here. And if you want, there's all the definitions, all the explanations on how we do that research. Another major study that we launched and we're continuing to do is mapping of the algorithms, primarily in the big data, HPDA, and AI area, against the different types of verticals and sub-verticals. And this is just, again, snapshots of the project. So this is just taking the first vertical, bio life sciences, and you can see all the subdomains that we've split it into. And then this particular table is looking at requirements, it's the complexity, security, and so on. But here are all the different columns in this whole structure. So it gets into whether or not machine learning makes sense, what type of machine learning, what kind of data mining, the hardware requirements, do processors, is that the key driver here, flops? Or is it accelerators? Is it the memory system or interconnects? And again, this is for about 45 subdomains by vertical. So this is intended to be an entire mapping of the application space. And then once we do the detailed mapping, we roll it up to the I think it's 8 or 9 verticals here, and we kind of color code which ones are crucial. So here you very quickly can see where desktop only versus clusters versus private cloud and public cloud are currently being used. So this is a snapshot of the current situation, and this is something we're watching over time to see how it evolves, because obviously a tremendous amount is moving into public clouds, and we're watching that evolution. And with that, I'm going to hand it to Bob.
Hi. Thank you. Am I on back there?
No, can't hear me. Hello.
There you are.
There. Oh my gosh! Well, that's fun. Wow, what power! Just quickly, one of the projects we've been working on for the last year or so is an attempt to really generate a geographical map of all of the relevant HPC centers of activity, which we're calling them, which includes universities, commercial sites from both a HPC producer and user base, and some limited extent of what's going on in the government world. And I think right now we have about over 800 different physical locations with a little packet of data that goes along with each of them, name, address, particular aspect of HPC that they're involved in. And what's interesting is you can search this by a number of different vectors. You can say, give me all of the HPC sites that are in this particular county in Los Angeles, and perhaps compare the demographics of that with a state of perhaps of, say, Massachusetts. So you can kind of cut the data a bunch of different ways. And because this was originally done kind of near my home base, Washington, D.C., you can also search by congressional district, which can actually be a very useful tool if you have a certain amount of agenda and you want to talk to your particular representative or senator to find out exactly where he stands, and just give him a sense of there are X number of HPC centers of activity in your particular district, and perhaps you should be paying more attention to that because there's lots of interesting reasons to do that from a political perspective. So just go to the website and you can look at this stuff and you can play with the search and download all of the data quite easily. But it's an interesting tool. It's a growing tool. We're trying to maintain it. Every time there's an election, we have to re-update at least that particular portion. But we really want to continue to add to the base. So if you don't see your favorite site there, just drop us an email and we'll make sure we can get them added on as we go forward. Just as a quick cut of some work we're looking at. Clearly, the Exascale Race right now, if we want to call it a race anymore, we're trying to keep track of what's going on and looking at the major regions of interest, China, EU, Japan, and the US. And this is really just our estimate of kind of the rollouts of not only the exascale, and we're calling them pre-exascale, near-exascale, and exascale systems that really try to capture the lineage of each region's goals in terms of developing an exascale capability. So certainly there'll be other large-scale HPC procurements in the interim here, but these are the ones that really speak to a lineage of moving onward towards developing an exascale program or indigenous capability. I'll talk a little bit about this later, but this is really just a quick snapshot. And if you look at the numbers here, we're talking really about a $9 billion commitment over the time period of interest in just looking at the race proper. I'll get a little bit more into this later, but we are really trying to get our hands around what's going on in the quantum computing world. When we first started this years ago, we always kind of considered it to be a subset of what was going on in the HPC market and felt that there was a natural confluence of interest here. But as we've really come to explore the sector, we believe that when certain technical issues are resolved, quantum computing will not really be a subset of overall HPC, but will find its way into many, many vast other regions of the overall enterprise IT infrastructure. And so the potential for quantum computing right now despite the daunting challenges, really will help not only drive some interesting new capabilities within the HPC sector, but also within the enterprise IT sector writ large. We'll get into that a little bit more. Now I'm going to turn this over to Alex, who's going to tell you a little bit more about a cloud assessment tool we've been working on.
Am I on now? Can you hear me? So about 6 or 7 months ago, we released our cloud tool. We just kind of got the first round of beta test data back from it. If you weren't at our last presentation, this tool is designed to help end users understand what parts of their workload are friendly to a public cloud system versus an on-premise system. So trying to find out where are the friction points for your applications or your workloads to understand where they can run. And it's an unbiased tool. You can go on our website and fill out the questionnaire. It's, I think, 13 questions. And the design of this tool is to be interactive with users. So if there are places that you feel that we didn't quite hit it, we didn't quite get the characteristic of the workload correct, or there's something that has changed in the past 6 months, please feel free to email me and we can talk about it. We want this tool to be evolving as the move to public cloud also evolves. This is a study we did looking at the biggest systems in the world. So what we're paying for the largest systems worth the performance we're getting out of them? And so you can see just on the price performance of the top 5 computers each year, it's a pretty linear trend. So you're paying for what you're getting. It'll be interesting to see as we project out whether our projections will line up with the Exascale Race as it continues, and if the prices will match the performance coming out of these really large machines. Recently, we also looked at how quickly the HPC market can change. About 14, 16 years ago, x86 came onto the market, and as you can see, totally started to dominate. So in looking at this as a study for how quickly buyer interest can change in a market with evolving technology, this is or will be available on our website, hopefully. And this is a new area that I've had a lot of fun researching over the past 9 months. AI is growing. Everyone's talking about AI, but the hardware limitations have become very apparent. So looking at what are the startups and the large corporations doing to address the needs from a hardware standpoint for AI workloads. So looking at things like Rain Neuromorphics making a neuromorphic chip, or the IPUs, and some of the more custom systems and pieces of hardware that are being designed to tackle the growing AI ecosystem. And with that, I'll turn it back to Earl.
Okay, great. Thanks, Alex. And okay, good. And as I mentioned, for each one of the slides you just saw, those are major studies we've done. I'm going to just pick on Alex's last one, for example, AI hardware. We're trying to do entire mapping of all the different AI hardware around the world, where it might fit, where it doesn't fit. And we're hoping to soon launch a study of very particularly, if you look at the AI hardware, where does it help scientific computing? You know, to actually do a mapping of that. So mapping that along with all the scientific computing applications in different centers. And with that, I'd like to walk through our usual market update. So 2018 was an extremely strong year. We saw over 15% growth on the server side. So as far as the server revenue now is $13.7 billion. The supercomputer segment is back into a growth mode. So we saw 23% growth. Much like tracking on the top 500, you know, we track what people actually spent as far as dollar-wise. For almost 4.5 years, the high end of the market was flat. I mean, almost no growth there. So it's good to see it back into a growth mode. I think based on Bob's chart with the exascale machines, we're looking at probably 4 or 5 years of very healthy growth. And then we're concerned, is it going to go, you know, back to another roller coaster slide? So we're researching that a lot. And the last bullet is one that we're working very heavily. Steve Conway and the team is leading this. And that is really, where does big data and AI affect the market? And right now, there's a fair amount of spending in AI, as I mentioned. But if you start having something that's growing at 25, 30%, you over-rely it on top of HPC, the numbers can be quite staggering. And we haven't quite worked that all in our numbers, but we're in the middle of doing that. So this is how the market shook out as far as our major categories, the supercomputers, divisional, departmental, and work group. And you can see supercomputers represented roughly $5.5 billion in server purchases last year. And here's how it looks by the major verticals. The amazing part to me is if you look at this chart, we have about 6 different verticals that are more than $1 billion a year, and we actually have 2 of them that are about $2.5 billion a year alone. So the growth here, even by the vertical levels, is just phenomenal. And if you're interested in more details on this, so this is, like I said, each of these are snapshots. We're tracking this by 28 countries. We go back in time 30 years, and in everything we do, we have to have 5-year forecasts. So we include 5-year forecasts on all this. So here's the vendor shares and the changes that are happening here. HPE is clearly the market leader right now and has been since IBM sold its x86 business to Lenovo. Dell is growing probably the fastest still as far as of the major vendors. The Chinese vendors like Inspur and Shugan actually have the highest growth rates from a percentage viewpoint, so they're doing the strongest there. Cray is, historically you'll see in one year Cray will have the highest growth rate, and the next year it goes way down. Cray still has this fluctuation problem. And the thing I just want to highlight about that, which is something we're just trying to figure out, is if you notice Cray's entire size last year was $313 million. And the announced wins right now with the Exascale programs are double of their entire yearly sale. One of the $600 million wins, the Argonne one's somewhere between $500 and $550. So it's a very difficult financial scenario. So I think with HPE acquiring Cray, that may help them or it may not. I'm not sure, but we're hopeful on that part. So it's always hard to tell, but part of the issue of the price tags of the machines moving upward, if you look at our list right here, except for the first 5 or 6 vendors, any one of those vendors that wins an Exascale machine of $600 million is talking about a singular sale that's more than double your yearly revenues. And from a financial viewpoint, that's very difficult. And if you think of the Wall Street or people or the financial people around the world, they don't like it when they love it when companies grow like this. They hate it when they almost triple in size and then go back down. So it's just a phenomena that we're trying to figure out how that's going to work out. So here's how the market's split up by regions. You can see that EMEA has been doing extremely well. 2018 was an extremely good year. EMEA grew by more than $500 million, is now $4 billion in size. And then if we look at the broader market, so everything I've shown so far is just the server portion. This adds the storage, middleware, application. And again, this service line here is just the repair services. This is not including professional services and other things like that. That's just the repair services. And you can see what overall right now we're expecting the total market to grow between 7 and 8%. I should highlight one change here is in the past almost 8 years, storage was growing 2% faster than the market. Storage now is growing right at market rates. So there has been a change on the storage side of the business right now. It does not mean that storage isn't just growing tremendously. This is the amount of revenue that the storage vendors are getting from all the storage. And Alex will be covering this more in detail, but this is a new version of what we call the broader market. The top blue bar is we're adding, it's a little apple and oranges, but the top blue bar is the spending in the cloud. So if you look at the bottom bar here, that's buying servers on-prem. The middle bar is the software, the other on-prem things, and then the top one is the cloud. And as I mentioned, Alex will cover in more detail, but the reason we showed you the tipping point chart is we actually think the cloud computing is going to go see 1 or 2 tipping points where it's just going to double or triple in 1 year. And I wish we were capable of forecasting stuff like that, but to forecast a tipping point is very difficult. So we're running a cloud computing survey every 4 to 6 weeks right now because we realize you can't forecast, but we want to see when it happens as soon as possible. And we're trying to very much track that. And with that, I'll hand it back to Alex.
So Earl kind of gave away a little bit of what I was going to talk about, but I'll try to give you guys some interesting stuff as well. So the cloud has been really, really interesting over the past few years. A survey that we did in 2011 said that just around 13% of HPC sites were doing something in the public cloud. And now one of our more recent studies has that number up to 74%. So people are starting to move to the cloud. But the movement to the cloud is quite shallow. Not a lot of people are moving a large portion of their workloads into the public cloud. They're kind of scratching the surface to see what they can do, to see where it fits into their ecosystem. So we're looking at what point is the cloud going to become much more important to an HPC center? When are they going to be moving 15, 20, 25% of their workloads into a public cloud? So that's something we're trying to understand, and that's why we're running so many surveys to see at what point are users going to start moving more towards the cloud. And there's been a lot of interesting hardware changes in the cloud as well. They're becoming much more heterogeneous, and they're offering a lot of different options of hardware. If you want to run on different kinds of accelerators, not just a standard GPU, Microsoft with their Cray offering, there's been some really interesting attempts to create diverse environments in the cloud to draw HPC users in. When we talk to users, we ask, why are you going to the cloud? Why are you looking at the cloud? And the top two always is surge and extra capacity and burst computing. So when your HPC center is full, you can burst into the cloud, you can use similar resources, and you can get through your solutions faster. And you can see that all sites versus government, they're all the same 5 reasons. The priorities are slightly different based on if you're in a government lab or if you're an end user site, but they're all the same reasons. So for our forecast, what we did is we looked at what are end users actually spending in the cloud. So we looked at how much are they spending on hardware, how much are they saying that they're moving to the cloud, and how do we reconcile those two numbers to figure out what their HPC cloud budget is. It's very hard to look at it from the cloud provider side. So it's easy for us. It was more prudent to look at how much are end users spending in the cloud. So this is our forecast out to 2022. And as you can see, we're projecting that by 2022, HPC users will be spending in the neighborhood of $5.5 billion on public cloud resources. And this is something that we hear. And I know I talked about the cloud tool in the opening, but this was the driving force behind the cloud tool, that we keep hearing the same comments from end users about the cloud, that cloud is only for embarrassingly parallel and that you can't do anything else, or that they're being pushed to look at the cloud and why aren't they in the cloud from kind of the upper level management. So we created the tool to help end users understand and answer these questions better. So as I said earlier, the cloud tool is based on observations drawn from research that we've done. And we want it to be interactive. So please go to our website, fill it out. If you have questions, if you have comments, drop me a line. I love to talk about this stuff. It's really interesting. And I'll just quickly go through. The tool it's a scale. We created a scale for various characteristics where one number, or the bottom of the scale, is for an on-premise system or an on-premise type of characteristic for the application. The top of the scale leans more towards the public cloud. And if your workload is somewhere in between, you get a score. That score is then aggregated across your entire workload of characteristics, and you get an overall average score to see where does your workload fall. Is it amenable to the cloud? Should it stay on-premise? Or is it somewhere in between that then you have to decide? And this is an example scorecard. So you can see the various characteristics that we've drawn out to try to tackle this problem. And so next steps, please go fill it out. Please email me if you have problems, questions, comments, anything. I'd love to hear from you. And I'll turn that over to Bob for quantum.
Great. Thank you, Alex. Appreciate it. To me, just before I get going on this, just quickly pause for a second. And God, I wish I had this deck 5 years ago, because the fact that we're standing up here and we're talking about things like cloud, we're talking about things like machine learning and big data and quantum computing in the HPC environment is, the tipping points are out there now in some sense that we haven't seen in a long time, and we're living in some really interesting times right now in the HPC world. It's expanding in a number of different directions, and I think it's a really exciting time to be looking at a lot of this stuff. So I said earlier, when we started looking at quantum computing, it was really thought as something that we were going to view as a subset of high-performance computing, and we have tracked it as such, but it really has blossomed into something more than that as we've looked at this sector and as it's grown rather enthusiastically. Well, simply put, the promise of quantum computing is substantial, and we see more and more interesting applications and capabilities every day in things like cybersecurity, material science, chemistry, pharmaceuticals, machine learning, and really one of the biggest ones right now is the ability to do optimization across a wide number of verticals to find the best potential solution across a range of things. And this list grows longer every day. It is literally a profusion of new and interesting applications of quantum. The issue here is that the challenges to bringing a quantum computer into a viable work environment is complicated. There are formidable technical issues in both quantum computing hardware and software. The performance gains are uncertain. You may, if you read the popular press, you think that people are going to be reading your email tomorrow because those algorithms will be broken, and we're going to be solving all sorts of intractable problems from a classical computing perspective. None of that is actually quite certain when you get down to the underlying theoretics behind it. So it's not as if quantum is going to solve all problems for all people. It has some very interesting niche applications and some very good use cases, but it is not the end-all be-all in terms of replacement technology. The time frames are very unclear. We've actually started to come up with we're trying to think about a market projection in terms of where the sector is going. And what you have to do is put a number of tripwires that certain things can't happen until certain goals are met. And when you try to figure out when those goals are going to be met, it becomes very, very speculative at that point. And those goals are not only technological, they're economic. And some of them are actually political, and some of them are more atmospheric. And some of them are actually kind of interesting in the sense that quantum is not developing in a vacuum. There are advances in other parts of the classical computing world. This is still, in some sense, a race in terms of which particular capabilities, quantum computing or classical, can actually move forward in an interesting manner. So don't think of quantum as existing out in this separate world. It is embedded in some of the larger IT infrastructure. Right now, there's a Wild West in application algorithm progress. If you look at these companies that are developing quantum, they're really not in the position to be the source of all the interesting algorithms and applications. And so if you have a really interesting quantum computing application that's been sitting in your back pocket for the last couple of years, dust it off and contact a company called Rigetti. And if it's really good, they'll pay you $1 million for it. Their crowdsourcing is really kind of a way to go. What we're seeing in the quantum computing world is access to quantum computers through a low-cost model in a cloud-based environment, and allowing people to kick the can on quantum computing and generate a cadre, basically an environment where people are sharing algorithm developments, application developments from that particular perspective. That's a really great way to cast the widest net as possible, but it doesn't really support a rigorous development of a formal program of application development. So it's something that has some good and bad points to it. And there is a significant looming workforce issues here. There just won't be enough quantum experts to go around, the kinds of folks that are actually doing the work today. We're going to need people that have job titles like quantum software engineer or quantum hardware engineers or application developers or systems development folks for looking at developing the quantum programming stack. None of these people really exist as of yet, and we're going to see some significant workforce problems. It's going to be hard to find these people, and the university system won't be able to turn them out at the rates that we think the sector is going to need them going forward. So if you have quantum folks that nail them down, keep them close to home, because they're going to be very attractive in the coming next few years. One of the interesting things about quantum, I just put this up, and actually this is a really great chart because what it does is for the HPC crowd, everyone knows about SecDet, the idea of, okay, single error correction, double error detection kind of stuff. Quantum takes that to a whole new level of requirements because these quantum qubits, the fundamental computational element of quantum computers, are just fraught with error. And the only way to make things actually work is to embed an awful lot of error correction into these things. And we're not talking about the HPC counterpart where you had a couple extra bits of error correction to correct 8 bits. Some of the theoretics here behind this are really pretty scary. And I'll just draw your attention to some of so Peter Shor, who's kind of a pioneer in this field, has come up with ways to basically look at just logic gates and can only requires 9 bits of quantum correction to make one logical bit. And that's only at the gate level. And if you look at some of the other things, and the Shor's algorithm, the ability to factor large numbers into their prime elements, that is causing all the concern about some of the potential encryption vulnerabilities in the coming years. It may require over 173 million physical qubits to actually decode a 1,000-bit prime number. So the issue here is with errors are absolutely horrendous, and this is going to be a major sticking point as the sector goes forward. So I just throw this out there because when you hear in the news when someone says, oh, we have a 72-bit system, or we're looking towards 100 qubits in the near future. Those are physical bits at this point. Those aren't logical. And they are dealing with the issues of error correction because those are very noisy. It's not just that the gates are noisy. It's when you initialize the qubit, it's noisy. When you measure it, it's noisy. When you do a unitary operation like a NOT bit, there's some characteristic noise. If you do a binary operation like an AND or some of the other fundamentals in the universal gate, there's noise. It's a significant problem, and we've actually, of course, we need jargon. We're now it's called the NISQ phase, the noisy intermediate stage quantum computing phase, which says we're going to be dealing with really noisy applications for a long time. And so the main thrust of the sector right now is how can we define algorithms that we can accept the fact that there's going to be a lot of noise in them and still get interesting answers. And so that's really where a lot of things are going on. In terms of trying to get to that next stage. So right now there are many developers out there, and I just threw out a few of some of the favorites here. There are perennial favorites in terms of IBM as a large research activity. Companies that you wouldn't expect to be out there. A company like Google is doing some really interesting work. They're not going to probably be selling product, but they're interested in it for their own insights. Companies like Rigetti and Microsoft are doing some interesting work, and there's a whole bunch of other ones. The bottom line is that they're all dealing with this NISQ environment issues. So we're looking at some of the key questions to be addressed, and none of these should surprise you. Leading trends in hardware, software development, time frames is a really big question. And the bottom line here is this is a really nascent sector, and we can't come up with hard answers. And so we're really just trying to get a sense of what is the general thematic trends, what are the significant challenges, and what are the significant advances in terms of what's really going on. I just want to give you a quick sense of what we're hearing when we talk to folks in the user base, the folks who are saying, okay, quantum is interesting, how does it apply to me? And the bottom line is there's no current business case out there. You cannot go to your board right now and say, here is the return on investment in quantum. And if you talk to folks, there's two general phases of why companies are looking at quantum right now. There's the unbridled enthusiasm group that think this is really cool technology and something interesting is going to happen. And then there's the fear of missing out group that just feels that this is a potential tipping point technology, and if they're not there when it actually hits, they're going to be left behind forever. So there's lots of maintenance activities. I'm going way too long, I know that. Okay, I tend to do, just grab me, I can give you tons of detail on this stuff later. So the bottom line in all this is how this plays out near term is there's quantum computing ramp up going on. You can generally get cloud access to interesting quantum stuff. IBM Q Experience and some other folks have some really interesting ways to basically look at quantum computing. You can play the game, lots of uncertainty, lots of problems, potential really great gains here, but there's lots of technical challenges ahead. Okay, I made that and I probably killed the time. Let's go quickly to the Exascale race. Just bottom line, all of the Exascale stuff, there are 4 major groups that we talked about. Basically, the race right now is the U.S. is really looking pretty aggressive here. I think the Chinese efforts are going to pull back a little bit. They may not be hitting the exascale mark in the way we thought earlier. Japan is going to roll out a really great machine, the Fugaku, in the next year or so, really well designed. And the EU has done something really interesting, which is they've kind of pulled back from the concept of a race and shifted the emphasis towards indigenous development. They had to buy themselves a little extra time to do that, but it's really worth the effort, I think, because they're developing some very interesting processor technology. It's a really interesting design. Think of it more as the ability to build a customizable chip using little chiplet applications so you can construct the kind of chip you need. Very flexible and will allow for lots of innovation at the computational level so different kinds of organizations can tap into different parts of intellectual property and build the chips they need to meet either the exascale systems that they're looking at. And I'm just going to, none of this stuff, we can get details later. As I said, right now the European Joint Union just as kind of a precursor to all this has announced the availability of making sure that there's going to be at least 8 supercomputers in the next few years that are going to be distributed around the European Union just to make sure that the environment grows and that there's a basis of capability within the EU. And as I said, this is the processor development, and this is they have a common architecture where you can actually start to add different little chiplets to make all this work in a very flexible manner. I think that's a really sophisticated design and something I'm looking forward to seeing how it comes out. So I'm going to stop talking and make these guys. By the way, I want everyone to see our schedule. It basically says start at 8:15 and stop talking at 8:50. So I completely subsumed the schedule. I apologize.
So for those of you who aren't aware, biannually we run, in conjunction with the HPC Steering Committee, User Forum Steering Committee, we run the HPC Innovation Awards. And the award program is designed to highlight interesting new uses of HPC in the community and to show people what's really going on. What are people doing that's interesting, that's new, that's revolutionary on HPC systems? And these are some examples of some of the previous winners that we have. And this is the trophy you get. So as I said, part of the program goal is to develop a large database of these success stories. But the other part is to understand return on investment for HPC. How do you justify HPC when you're buying a new system? And this program is aimed to help explain why HPC is so important. So if you choose to apply, and I encourage everyone to apply, the most important thing is about you have to kind of accomplish these three things. So you have to look at what's the dollar value of the project for the return on investment, what was really accomplished, but then part C is really where we distinguish the winners, which is what did you do to help society? What is the benefit of your project on a larger scale? So rather than did you do something cool, how is that cool thing going to impact the world? And here are the winners. So the first group, the first winner is Wendy Tam Cho and Yan Liu from NCSA, who created a really interesting algorithm to understand redistricting and gerrymandering in elections and looking at how HPC can help to redistrict for vote counting in the United States. So if there's a representative, please come up and accept your award. Thank you so much.
Congratulations.
Our next award is for Project Disco out of UC Davis and NERSC. Adam Rupe ran this project. And this was an interesting project about coherent structures and looking at a new way to look at them with HPC. If there's a representative for the Project Disco, please come up. No? Well, let's give him a round of applause.
Oh, okay.
Thanks, Joe. I appreciate it. Our third award is from Lawrence Livermore, and they used AI to find different modes in laser-driven fusion. So looking at AI and how can it kind of look at the different parameters for some of these really interesting projects that they're doing. Really, really interesting stuff. Is there a representative from Livermore? Thanks, Brian. Congratulations. And our fourth is from the University or the Caltech. I'm sorry. Looking at hidden earthquake research, so looking back over many, many years of data and using HPC to discover all these new smaller earthquakes that we had never recorded before, and looking at how the different plates shift and how you can track all of these mini earthquakes that don't register for us but are actually really happening on the plates beneath us. So let's give it up for Caltech.
I'll stand right there in front of the camera.
Yeah. Can we have all the award winners or representatives in front for a quick picture? And quickly, please apply it's open for applications now for SC, so please come in and apply. And if you have questions, feel free to email me.
Go over and shake your hands.
Yeah. Thanks, guys, again. Thank you so much. Thank you. Do we have a picture? We get a picture? Cool.
The camera's rolling right there.
Oh, perfect.
Great, thank you very much, then. And then in summary, we wanted to cover just a few predictions that we have for next year. As everyone knows, the Exascale Race is driving new technologies. In addition to the new systems, I wanted to put on here driving new price points, but that's pretty obvious. on that part as far as the cost of systems. But the interesting part for us right now is we think, and there's many talks at the conference here, that we're entering a new phase of technology for HPC. And it's driven a lot by Exascale, it's driven by AI and other things too. But as far as the different types of systems, architectures, processors, there really is a whole new family of technologies coming together. And that's something we will be tracking. But we expect to see a tremendous change in the core technologies and how machines are built. The next one is we refer to the HPC enterprise market convergence. And what we're referring to here is what we're seeing is a lot of non-HPC sites, the traditional commercial computing sites, are now moving to HPC solutions. And it's driven a lot by AI, it's driven a lot by big data, but it's also driven by the desire to do bigger and better things. And what they're finding is, all the lessons learned in HPC are useful. So we're actually right now trying to figure out how to actually categorize and track this in more detail. But it's a major shift that we've been seeing for a while, but is accelerating. As mentioned earlier, too, and Alex had a tremendous chart in AI, the number of new processors on the market right now is just phenomenal. AMD has come out with some great solutions right now. ARM is coming out the door. Fujitsu with the Fujitsu ARM at Riken. The EU is making major investments. And I'm not even sure in China how many new processors there are. I know we're tracking 7 different product families, but I think there's probably more. And on the AI side, it's just tremendous. So a lot of new processors and accelerators. And it'll be very interesting to see how they all profile and where they fit in the market. We are expecting that the typical looking HPC system 5 years from now may have more than 4 different types of processors in it. So we think we are migrating to a place where the complexity of the system is going up. The storage systems will increasingly become more critical to the whole design. And everyone has been seeing presentations on, the whole issue of do you move processors closer to the storage, move the storage closer to the system? Do you put flash memory right, on the nodes with the processors? We think there's going to be a whole set of solutions here because the whole issue is if you look at just the data explosion at a site as far as what's being processed and what's going on in the machine, something is broken already and has to be solved. And also cloud computing. As we've mentioned on the tipping points, the cloud tool, and our cloud forecast, we think cloud computing offers some very interesting things here. And I'd like to just take a second and go back to the tipping point that Alex showed. When x86 became good enough, not only did it replace the other RISC processors, if you notice, the actual processors being sold and the size of the market just went up dramatically. We think cloud computing is going to do the same thing. We think the first phase of cloud computing is actually additive to the market. And we think we're going to see some tremendous growth in the overall use of HPC. And artificial intelligence is just going to grow faster than everything else right now. I know there's been some debate over is there a nuclear winter that may happen again or whatever. At the moment with AI, because AI is not sitting out there by itself. It's really getting combined with big data. It's being combined with other things. We see AI really taking hold and continuing for quite a long time. And so in conclusion, we do feel HPC is a high-growth market. The HPDA AI machine learning, deep learning is growing the fastest here. It's interesting because we were going to drop the third bullet there about vendor share position shifts because it seems every 1.5 to 2 years is a major shift. And then with the HP Cray one, we decided to put it back in. So our guess here, there's actually going to be a whole other set of vendor share changes, in particular the acquisition of the AI startups. We think and many companies are going to be acquiring AI startups and other startups too. And the last point that you continually hear from us is software just lags everything right now. We do a continuous set of studies on certain areas, and one of them is we're trying to map all the applications on all the HPC systems, the actual job runs. 29% are still running on one core. And if you go to 50%, 50% reside on one node. So if you look at just all the jobs running on all the machines out there, the software has not scaled. And I'm not talking about petascale scaling. I'm talking about just getting off of the node. So this is an area that clearly is out of alignment with what's going on in the industry. And last, just wanted to invite everyone to join us for our next round of HPC User Forum meetings. As I mentioned, we have 2 in China, then Argonne, and then 2 in Europe. And with that, I'd like to thank everyone. I think we have time maybe for a minute or 2 of questions before 9, if there's any questions at all.
So this difference between machine learning, deep learning, and why you think deep learning growth is declining or not as fast.
Right.
What are the reasons for that?
Right. So, machine learning is really where you have more control over it. You give more guidance and rules to the whole algorithm than that. There's a whole issue, and again, we have multiple studies, and so we're glad to share that with you. But one of the big issues is transparency, to really understand what's going on when the decision happens. And we think that's what's holding back the deep learning from taking off as much as we were originally expecting. And the machine learning, people kind of understand it, and they know how to use it on that part. Okay, great. Well, with that, I'd like to thank everybody and enjoy the rest of the show.